In our properties of logarithms homework, there are a few different properties we want to be doing, and it's broken into two parts. The first part is expanding, which means when we take a bunch of things that are inside of a logarithm and move them out of a logarithm to make the logs individually as small as possible. This will allow us to evaluate and do a bunch of things with those individual parts sometimes. The second part is going to be condensing, which means putting everything into a logarithm, which again will sometimes allow us to be able to do some things with that log. This first example I'm going to do is when we have log base 3 of 9x to the 4th power, we might notice a couple things going on. 9 is multiplying times x, and this whole thing is being raised to the 4th power. There are a few properties we should know. The first of the main properties we're going to be using is that log base anything of two things multiplying together is the same as that same log, same base, with the two things that we're multiplying split into two separate logs. So if we have two things multiplying together, we can split it into two separate logs. Our second property is that if we have two things that are dividing, we can split that into two logs that are subtracting. And our third one is that if we have log of something to a power inside of the log, that power can come out front and multiply times the log. And we talked about in class why these are true. Here, it might look like we have something multiplying, but we don't. This is something multiplying to a power. And this rule wasn't if there was something multiplying to a power, it was just if there was something multiplying, and that's not what we have here. Instead, we're going to need to start with our property over here, which says that if you have something to a power, you can do something with it. We have something to a power. 9x is to a power. And so our first step is to rewrite this as log base 3 of 9x, and instead of having to the 4th power, we're going to multiply times 4 in front. Now we'll notice that it is log base 3 of just two things multiplying. And so now we can split this up, but we're going to be a little careful here. This log is getting multiplied by 4. So when we split it up into, again, using our first property, this is log base 3 of 9 plus log base 3 of x. Since this whole thing was getting multiplied by 4, and now it's a sum, we need to make sure we put a parentheses around here so that the 4 will multiply times both of them. It's 4 log base, log base 3 of 9 plus 4 log base 3 of x. And now at the end, we have it broken up. There's nothing inside the logs that we can make smaller. We want to see, is there anything we can do to evaluate the logs? And we can here. We've got 4 log base 3 of 9, and that's 2. So this is 4 times 2, which is 8. Log base 3 of x cannot be simplified, and so we get 8 plus 4 log base 3 of x. I'd like to point out that here we had to do the exponential property first because there wasn't just any two things multiplying. It was two things multiplying to a power. But if you compare it to this other one right here, now we aren't going to move the 4 to the front first because the whole thing isn't to a power. Only x is to a power. And so it's not log base 3 of something to a power. It's log base 3 of 9 times something to a power. And so the first thing we would do here is split it up into two different logs, and the 4 would not come out in front first, and you'll see how it come up with a slightly different answer. Let's do a different property. Here, we have log base 4 of something to a power. And this one, I noticed there's something multiplying, there's something to a power, and there's something dividing. Well, the question is, what's it actually a log of? It's not log of something to a power because the 4 isn't to a power, only this part is to a power. It's not the log of two things multiplying because these things are being multiplied and then taken to a power and then dividing. What this is the log of is two things that are dividing by each other. And so we're going to start with our second property, that if we have the log of two things dividing, we can split that up into the log of the first thing minus the log of the second thing. Now we'll notice that this first one is the log of a whole thing to a power. So this can come to the front. Again, this is two things multiplying now. We've got 16 times x. So 16x is 16 times x, and that can be split up. I know this 3 is in the front, and so when I split up, I'm going to skip this distribution step by saying it's going to be log base 4 of 16 plus log base 4 of x, and I'm just going to go ahead and multiply them both by 3. 3 log base 4 of 16 plus 3 log base 4 of x minus log base 4 of 4. There's no logs that can be split up on the inside of the log, so I'm not going to use my properties of logs anymore. Instead, I'm going to try to evaluate some things. I can do log base 4 of 16. 4 squared is 16, and that's what this is asking. What exponent goes on 4 to get to 16? So this is log base 4 of 16 is 2. 3 times 2 is 6. This is log base 4 of x. And log base 4 of 4 is saying 4 to what power gives us 4, and that is 1. We can combine like terms and get 5 plus 3 log base 4 of x. I'll do one more on this page. This one right here is a little bit weird. It's got a root, and we don't have any property of logs that had roots. So we're going to need to use a property of exponents here, which is that we know anytime we have a root, we can rewrite it as a fraction exponent. So that's going to be my first step. So I'm going to rewrite this as log base 2 of 4x to the 5th, y to the 6th, to a power. And to get a root, we need a fraction power. This is the 1/3 power. And now that we have it as a power, we can use our property of logs number 3 that says that if you have something to a power, that can move out front. So this is 1/3 log base 2 of 4x to the 5th, y to the 6th. I'm going to split this up, and I'm going to say it's 1/3 times log base 2 of 4 plus log base 2 of x to the 5th plus log base 2 of y to the 6th, because these were all multiplying together. So I'm going to split them up into an addition of separate logs. The last thing is we've got 1/3 times, I can evaluate this one. Log base 2 of 4 is saying 2 to what power gets you 4? The answer is 2. Here I can't do this, but I can move the power to the front, so I'm going to. Here I can move the power to the front again. Oops, this is a 6. And I'm multiplying this by 3. Multiplying by 3 is the same as, multiplying by 1/3 is the same as dividing by 3. So 1/3 of 2 is 2/3. 1/3 of 5 is 5 divided by 3. This is 5/3 log base 2 of x. And 1/3 of 6 is 6 divided by 3, which is 2. 6/3 is 2. And so there's my simplified answer. On the back, I'm going to do a couple here. Again, we're using those same properties of logs, but this time we're trying to combine them into a single log. And sometimes this is very useful. If we have log base 5 of 75, we can't evaluate that. I don't know what power 5 goes to get to 75, and I don't know what power 5 goes to get to 3. But I know I can combine these into a single log using property 2, which says that if we are subtracting 2 logs, we can go the other direction and combine it into a single log. This is log base 5 of 75 divided by 3. We can simplify 75 divided by 3. 75 divided by 3 is 25, and now we can do this log. 5 to what power gets us 25? The answer is 2. Here, we don't have any property of logs that says what to do if there's a log divided by a number. So instead, we're going to be smart about this and realize that there is a property that if it's multiplying by something, we can move that to a power. And dividing is the same as multiplying by the reciprocal. Dividing by 2 is the same as multiplying by a half. So now I can do, I have 1/2 times a log. That can go as an exponent. Log base 3 of 64 to the 1/2 power. And just like on the front, we have to be smart and recognize that if we have something to a fraction power, that is a root. 64 to the 1/2 power is the square root of 64, which we can do. This is log base 3 of 8. Do one more here. Here we've got a negative in front, and there's 2 ways to think about this. The first way is this negative is the same as a -1, and we can do 2 to the -1 power. So 2 to the -1 power. None of these other ones have a coefficient, and so I don't need to change that. But I'm going to do 2 to the -1 power. This is 1/2. Remember that a negative exponent tells you to divide. And now I've got 3 logs adding, and so I can multiply them into a single log. It's 1/2 times 3 times 4. 3 times 4 is 12. Half of 12 is 6. This is the natural log of 6. There's another way to do this, though. I could have, if I have negative natural log of 2, I could have just rewritten this as natural log of 3 plus natural log of 4 minus natural log of 2. And now we can see that these two will add together, natural log of 12 minus natural log of 2. Now we have a subtraction between 2 logs, and that's the same as dividing. And so there's 2 different ways to get to the same answer. All right, I hope that helps on your homework. Good luck.